So if you're here to hear me say, plow up your end-of-fight affected fescue, you might as well leave now. I am not that person. I'm sorry. I like fescue now. You're going to see a slide in here. It says, what the heck is fescue? Because I come from Frederick, Oklahoma. That's in the southwest part of the state. We have buffalo grass, wheat pasture, Bermuda grass, Sudan, prickly pear, and cactus and mesquite trees, and that's it. And so if you're here to... All right, guys. We're going to do it this way then. Vitor. There we go. All right. So we always talk about building the foundation first. And so when I'm thinking about going to a herd and we're talking about AI, reproduction, ET, I'm a big ET guy. So whatever we're talking about, first thing I always like to talk to my producers about is, do they have the foundation? And so again, if they don't have the nutrition, and when I mean nutrition, that's forages. We're a forage base. Here in Georgia, we're forage base. In Tennessee, do we have the forages? Do we have that nutrition? Do we have the genetics that are going to fit our environment? Do we have the genetics that you want to market? And then the last thing is facilities. Do you have the facilities? Because if you don't have any of those, then why am I worried about that other part? So again, I need that foundation so I can build the program. So again, when I get started on talk, Saulo keeps wanting to steal my slides. These are things that I want to think about: herd health, calving season, repro, but I need that foundation to build it. And this is where fescue comes in during that time period. So when I say, what the heck is fescue? You got to remember, I left southwest Oklahoma, left Oklahoma State. I went to a school that I asked to let Georgia beat them on Saturday. I went to Clemson, and I actually called and said, please let Georgia beat you so they'll get overconfident and Tennessee can win finally. But I went out there in 1985, and all I heard about was fescue, fescue, fescue. And I thought, isn't that a yard grass? Isn't that something you put in the yard and keep shaded and it grows and things? And D. Cross and John Spitzer and all that bunch was there working on fescue. And I learned real quick. Kevin was there, real quick. This is a different environment from what I grew up in. This is a different grass. And a grass that will grow on a piece of rock with no rain. It's a good hardy grass and everything. So I went down and I interviewed and I took a position at Tennessee, and the dean came up and he called me in, and this was 1994, so a long time ago, and said, hey, I want you to look at fescue. And I'm sitting there going, we've been working on fescue for 30 years. Yeah, it decreases gain. Yeah, it decreases fertility. We know all that. He said, but why? He said, you're a repro guy. Why? And so when I'm doing my ET work, and I'm also doing that, and we've been working on it for years and years with tons of collaborators. This isn't a one-man show. This is a whole group of people. Sarah Orr's over here. She was around there when we were working on it, things of that sort. There was a whole group here. So again, we know reproductive efficiency is decreased. We know the goal is to increase that reproductive efficiency through AI, through ET, through natural service, however you want to do it. Not having a calf, they don't bring very much money when there's no calf. Got to have that calf. And so we know that tall fescue will cause problems, the end-of-fight infected tall fescue. In my state, they're going around saying plant novel, plant novel, plant novel. Years and years ago, and I don't see much of it left. I'm hoping these new novel varieties are better. I'm hoping. And things of that sort. But, you figure, you look at these and you look at that, that's the poster child of fescue, as I say it, that long, shaggy-haired cow. And when I first got to Clemson in June of 85, they said, hey, go out and preg check the cows. And I went out to preg check the cows, and John Spitzer, my mentor, sitting there, and he's going, she's open. And he wasn't even in the cow. How do you know? Look at that shaggy hair coat. And sure enough. And so, again, it was one of those, that's what I always call the poster child there. But if you think about our cattle numbers, and then you overlay where fescue is. I mean, you can see that that fescue is a big part of a large number of cattle. And so again, it's one that is important. And so I'm going to get into the weeds, and I apologize right now, but I'm going to show you some research that we've done. We're going to get into some weeds and recognize that when you study research, there's different levels of severity. We try to keep things as common as possible, but there's tons of anecdotal evidence out there around that, hey, if I get a hot pasture, stockpiled fescue and drought, boom, that's a disaster waiting to happen. Got weeds issues and things like that. I've got a spray for weeds. I wipe out all my clover. Boom, I got problems. I got hot pastures then. So again, those are the extremes. I'm not talking about the extremes in the type of research that we do. I have to show this slide because people always ask about fescue, and Gary Bates has shared this slide. You've probably seen it a million times. That shows the energy needs of a spring calving cow, and then when you have fescue. And again, it's around. And so it's one that is available and it's there. And I'm preaching to the choir because if you've got fescue, I guarantee you have managed around it. You know how to fix it. You've already done it. And so Troy and I were talking on the way down from Tennessee. You don't hear a lot of discussion on fescue any longer. Sarah, you hear much around you? No. Because our producers have selected animals that can handle it. They know the ones that don't grow well, you don't keep as a replacement. They know that old shaggy-haired cow ain't going to work. Don't keep the heifers out of them. We've selected. We've managed. And I've heard that term over and over and over today about management. And we've managed around fescue. Now, does it still be a problem? Yes. We have those cases when we get some hot pastures and it can be a problem. So again, there are benefits. That tall fescue, like I said, very drought tolerant, pest resistant, easy to establish, has a longer growing season. I mean, you're going to get it here September when it gets cool into 1st of October, and it's going to go all the way around to 1st of June or so till it gets hot. And so again, you've got some good, but you also have some bad. We know you have the decreased feed intake, you have the decreased gain, circulation, you've got the fescue foot as we see it, the respiration, rectal temperatures, yes, they're up. And usually when we see fescue issues, it's a combination fescue and heat. It's not just the endophyte, not just the ergovaline, it's when we put it together with the heat. So when we get into that end of May and June and when it gets hotter, okay? So again, several female issues. There's tons of papers out there talking about embryo quality, recovery, things of that sort. We're going to go through some of those. And there are papers that show where there are effects that are different from what we're going to show, and recognize that's due to differences in severity. Okay, so one of the first things I wanted to do after the dean came in and the dean said, this is what I want you to figure out. He said, you know, you do your embryo transfer work and you do all that, but you need to figure this out too because I'm paying you. So we wanted to see when the loss was going. And luckily, I walked into a situation at Tennessee where there was a 3-year project going on with 200 heifers a year that were either on endophyte plus pastures or on the novel fescue or on orchard grass. So I walked into the perfect situation there. And so we would go in and they would wean these heifers. They would put them on these 3 treatments. They would take them off for about a month and a half period, 2 months, and they'd breed them and thing. And then my job, since I could do ultrasound, I could go in there at 30 days, 35 days, call them pregnant. If they were pregnant, we would put them back on their respective treatment, be it orchard grass, E+, or novel. Okay? And so that was what we called study 1. And what we did was then how many of those that we called pregnant at day 30 to 35 had a live calf at the end. There was no difference between treatments. We didn't see the loss that others seen. Recognize this was a moderate level fescue, more than likely what you have going on at your farms. Okay, it wasn't severe. Okay, so again, we didn't see the difference. But, you know, me being a scientist, I'm sitting there going, you know, I bet it's uterine impact. There's uterine influence on gonadal development. And, we couldn't take the ovaries out of all the heifer calves that were born, but we could take the testes out of the bulls, right? And so the bull calves that were born, within 24 hours, we would go in there, remove the testes, and we'd weigh the testes, and they'd send me the data, and boy, I was on to something here. That testicular weight was reduced in those calves that their mamas were on E plus fescue. And I'm like, man, I've got something here. And I said, send me the birth weight. And grams of testicular tissue by birth weight was exactly the same across all three treatments. The calves were lighter. Those cows, when they calved, were in lower body condition, i.e. the nutrition effects that we're talking here. And so, again, it had nothing to do with the fescue per se, direct. It was cows were in poor body condition, calves were lighter, grams of testicular tissue was the same. Now, I do not say this for you to go back and say, I know how to solve my calving problems. I'm going to put my cows on fescue and have them have lighter weights. Do not do that. I am not saying that. We had some folks that become the report. Schrick says put your cows on fescue and they'll have lower birth weights. No, I am not saying that. I'm just saying that's what we saw. I do not recommend it because it was a hard time getting those lower body condition heifers rebred to have that second calf. Okay, so do not take that. Oh, Schrick said the calves were lighter. We can do that. No. Okay, so the next period I wanted to look at was we went in there and we looked at what was going on during the estrus cycle. Everyone says pregnancy rates are lower. So what's going on? And so we went in there and we looked during that estrus cycle right before we bred them. So they had a complete estrus cycle. Then we went in, we ultrasound the follicles, the CL, we measured progesterone, we did all that fancy stuff, and then we bred them when they showed heat. Okay? And so ovulatory follicle, ET, endophyte, all the same. Wasn't any difference in how the follicles grew. Okay? Went in there and looked at luteal function and progesterone. No difference. But then we bred them, and boom, there's our lower pregnancy rates. So again, why are we getting lower pregnancy rates? Everything's the same. Corpus luteum's the same. Progesterone's the same. Follicles are growing the same. But Pete, we didn't look at ovocytes. And so then I got smart and married one of Pete's PhD students, and who works on ovocytes and embryos and stuff like that, much smarter than I am. And the next trial we went in and we decided we wanted to look at day 7 out to day 30, 35 when we preg check. And the reason we were hitting that was, again, I do ET work. Okay? So day 7, was it a uterine effect? So is a uterine. So we went down south, found some Charolais cows that were on Bermuda, never seen fescue in their life. We superovulated, flushed those cows, froze the embryos, brought them back, and then we put them into recips that were either on the E plus or on controls. And so I show progesterone, and that's because progesterone and preg rates were the same. We didn't see any impact upon pregnancy rates when we put those embryos in those cows. So the uterus seems to be fine. And we've repeated this 3 different times, and we get the same numbers. Okay, so we're not seeing an impact on the uterus. So again, that gets me back to the ovocyte. So the final study we did was, okay, we're going to go in there and we're going to not superovulate because we didn't want to superovulate. We didn't want FSH to mimic what may have been a fescue impact. So we single recovered these animals here. Got one embryo out on day 7. So we should have been somewhere in that window with where the embryo should have been. They should have been in that window of time in terms of development when we flushed them. And boom. Our development was down, our quality was down in those that were on fescue. So again, if you look at there's our preg rates from study 2. There's our embryo quality from study 4. So we're pretty confident that we're getting oversight. I mentioned the fescue and the heat effect. Pete's going to talk about heat tomorrow, right, Pete?
Yes.
Goes right here.
And fescue.
There you go. So again, I think you're seeing some of these things that are tied together, and so they're going to be there and related. And so again, on the cow side, we believe that effect is there. Now, can I give you a silver bullet? Kai, you got any silver bullets? Yeah, I have no silver bullets, guys. We're already doing silver bullets. Silver bullets is called management, and we're already managing. We're selecting the right cows. We're managing our pastures. We're planting clover. We're providing extra nutrient, big corn or silage or whatever. When we get those hot windows and when endophyte's a problem, we know what we're doing. Okay? So again, we can manage around this. Now, I cannot manage around when you went in there and you fertilized in September to get some stockpiled fescue, and it doesn't rain, it doesn't rain, it doesn't rain, it doesn't rain. It rains in December, grass goes whoosh, and you put those cows on there and their switches start dropping off and their ears start sloughing off and everything like that because the pastures are hotter than a tick. Can't control that. So you see that happen, get some extra feed out there, you can dilute this issue. It does have a dilution capability. Okay. So that was the cow side. So we know the cow's half the equation. What about the bull? Okay, so then we decided we're going to get into the bulls and see where the bulls are in all this. And so we know that there's some effects on scrotal circumference. We know serum prolactin is going to be reduced. Rectal temp's going to be up. Is there some vasoconstriction? Probably. And so first thing we wanted to do was get in there and look at that effect. And so we went in there. One of the first studies we did was look at thermography. And so the veterinarian that we were using, Fred Hopkins and then Tulio Prado, we had to hide them. They could not see these animals because they were on fescue, kind of shaggy, you know. They can't look because that would have biased them. So we put them in a closet with no windows, true, with a microscope. That's all they had, and we'd bring it in there. But I was the one that had to take the thermography. I didn't know what bull was what bull. I mean, it came in, it's in pasture A, pasture B, whatever pasture it was in. And we had the thermography camera, and I went through the training, and we had a little string that we would put in so the distance was the same. And these are some of the pictures that we would get from thermography. We would record this. We would take the little dash drive back to the vet school. The vet school would do the analysis and send us what the testicular core temperature was based upon these. And so me taking it, I was grabbing the scrotum to get a good picture, and I noticed some of the scrotums were really, really cold. And I'm sitting there going, yeah, that's a control. That's a control. It's cooler temperature because the rectal temperature is up, so everything should be hotter, right? There's your E+ stall fescue. That blue right there, look where it is. So again, that vasoconstrictive action is all the way. That scrotum is an extremity. So again, look at where it's occurring. Right where the epididymis is. Where's sperm mature? Epididymis. And so again, it's right in that area right there. And if you look, you've got the non-toxic fescue, the E+, and then the E+ with clover. And so you can see the impact that we're having. So we're cooling those scrotums more, probably due to vasoconstrictive. What is that vasoconstrictive activity doing? I mean, what impact is it having on nutrients getting to the sperm, on hormones getting to that seminal plasma, things of that sort? We don't know. That's for the next person, Salo or whoever, that wants to pick up fescue and run with it. Okay? I'm retiring. That's not going to happen. All right? So some of the things we saw was we went in there, and again, we had people who were blind. If you don't know who Fred Hopkins is, Fred Hopkins on the first guidelines for theriogenology for breeding soundness exams, there were 3 authors, Peter Chenoweth, John Spitzer, and Fred Hopkins, who wrote the guidelines for doing BSE scores for the Society of Theriogenology. So we had Fred Hopkins who did all these here, blind, did not know. And this is what we saw. When we look at the semen and everything, it looked pretty normal. We didn't see anything that would really stick out that there was a problem. And this was not just one study. This was not one set of bulls. This was over and over and over, and at other universities. Clemson's seen the same thing. Scott Pratt down there. Okay? So, but when we put that sperm in Dr. Edwards' in vitro system, then we saw this reduction in cleavage. Let me make sure I hit the right pointer here, guys. So you see this reduction in cleavage here. Now, our blast rate was similar, but look at our cleavage. Our cleavage is being reduced. Okay? And we were thinking, well, that's just a fluke. This is just one. And we did it again, and we did it again, and we did it on 5 sets of bulls. And then Clemson's doing it, and they're seeing the same thing. So we're seeing an impact of this sperm. So why? Is the sperm not penetrating? Is it not recognizing the ZP3 receptor? What's going on? I mean, this is befuddling me, what's going on. So we brought in about 20 bulls. We went through those 20 bulls. We identified bulls that passed the breeding soundness exam, and the semen would also freeze in a soy base extender. So not only did they have to pass the BSE, but then when we froze the semen, it had to freeze and handle a 3-hour stress test. Once we identified those, we narrowed it down to 6 bulls. We put half of those out on a max Q pasture, which is the novel, the endophyte free, and we put the other 3 on E+ pastures, no clover. Okay, no clover, just pastures. Okay, and then we collected them once a week, and we tried to mimic, the breeding period in Tennessee. For spring breeding, those guys we start breeding about middle of April, and we'll go to the middle of June or so. And so we were collecting them once a week, trying to mimic that. We went in there, we did some penetration assays. We also did some calcium assays, which I'll show you here, which are really cool, that we don't know what the heck it means, but it looks cool. Again, looking at gross motility, again, these bulls, if you look at their semen, non-toxic, 90, E+, 85, 86 in terms of motility. Look at normals. I mean, again, there wasn't any problem with the semen. Okay, it was good. We collected the semen. We would freeze it once a week. We come back. We do our IVP test once a week. And again, cleavage is reduced. So is it not penetrating? What's going on here? So then we went in there, again, showing past studies that also showed a reduction in cleavage, either the ergotamine tartrate or the grazing studies, every single time. Our blast development, again, it's not an all or none thing. That's why if you got cows and they're grazing fescue and they get pregnant, guess what? It's not an all or none. Some of them will get pregnant. They form blasts. They're good. Okay? Then we did a stress test. We did 3-hour stress tests. Okay? So we took these bulls and then we thawed semen, and we had on there what their gross morphology was, what their pre-freeze was through the CASA. Then we did a post-thaw. Then we did a 3-hour post-straw, and then looked at the difference. So again, you can look at our non-toxic. Post-thaw, they were at 58. 3 hours later at 51. I'll take that. I'll take that on stress test any day of the week. But look at the E+. Post-thaw, 53. 3 hours later, 23. So again, look at that drop. Now for the bull stud guys in here, Polar still around, or did he run off? Y'all going to keep this semen, or are you going to dump it? You're going to dump it. So again, this is something that I gave this talk up at Lexington years ago, and Roy Wallace was sitting in the back of the room chewing on a cigar, not lit. And I walked by there, and he said, Schrick, he said, I could have told you that about 10 years ago. He said, we know about this. And so again, this is not something new, but it's something I want you to be aware of, that again, we feel the membranes on these heads of these sperms are very fragile. One of the things we notice is when we look under that regular, what I call regular BSE scope, everything looks normal. I go put this sperm under a scanning electron microscope, it looks like they ran into a brick wall. The heads are flat. Maybe some early acrosome reaction, maybe some capacitation going on due to the environment in that epididymis. I don't know. But they look like they ran into a brick wall. You wouldn't see it on a regular scope. But when you put it under a scanning electron microscope, boom, there it was. Okay? So some of the other things was we were looking at CASA and using that to measure speed and things of this. Mike Looper at Arkansas had done some of this work, and he also mentioned something we saw. If you look at this, the non-toxic, and then look at the E+, you see more what we call static sperm. The heads are kind of sitting there not doing much, not moving much. We didn't report that first. Mike Looper saw it. We saw it. Now Scott's seen it at Clemson and everything. So again, that head, the sperm of the head seemed to be slower. And again, this wasn't something we saw in these bulls on the earlier studies in January. Those earlier studies we collected January, March, May, into June. We didn't see an issue in January, cooler temperatures. We didn't see an issue in March, cooler temperatures. In May, we started seeing some of the impact on cleavage. In June, boom. So again, this is something that I very much believe is related not only to the E+, but it's a combo, E+ with heat. Okay? So in terms of penetration, we did see a decrease in penetration in these bulls, so less sperm did get in. And when you think about that, is some of the membrane issues, some of the freezing thaw issues. When sperm goes, it binds to that ZP3 receptor, pushes the elevator button, goes in. Okay? Is there an issue there? Okay? The ones that did get penetration, we saw some other things. Of those progression of the chromatin, you can see there's an advance in that. That was something that surprised us when we looked at those. And then this was the really cool stuff. We looked at calcium. So when the sperm penetrates, you get calcium oscillations. That's the resulting fertilization. What we saw when you fertilized, when the sperm actually penetrated and got in, that the calcium oscillations were reduced in those compared to the E+, or non-toxic. So again, you had a reduction in calcium oscillations, which are important for fertilization in that process, when we did with E+. So again, something to keep in mind when we, like I said, we got into the weeds there, but I wanted to get into the weeds to show you the depth that we're going into. Now there's others that are continuing on. Scott Pratt's still doing some work on it. Salo, I hope, picks up the road and keeps going, because I get questions all the time. If I put my bulls are raised on fescue, and I put them in a test station. Where's Duggins at? Put them in the test station, and they're off fescue for 85 days, 104 days, whatever your test station is. Do they lose that adaptability? Do they lose that when you go back and someone buys them and puts them back? I don't know the answer to that. So again, there's some questions that we still don't have in terms of, are they acclimated? Are they adapted? I can't answer that question. So what happens? I can give you tons of anecdotal. That's not science. And so, again, I don't know what those are, but I'm hoping the young fellas in here and young ladies in the room will pick it up and take off running, because there's still questions to ask. But you're doing the right thing. Again, I'm preaching to the choir. You have managed. You have selected. You have picked. So again, I think that's why it's not talked about as much anymore, Sarah, is we've managed around it. Okay, so how do we prevent these? Again, we talked about, Salo talks about his fall heifer consignments filling up. And so again, you're seeing more folks that are switching over to more of a fall because they know that then you don't have the temp issues and things like that. So there are some that are moving over to fall. But there's others also that are looking at making sure they have clovers in their pastures and other feeding sources to dilute the effect. You can dilute it. And so there's other ways to do it. And then they're purchasing animals that have adapted. They're not going somewhere and buying animals that have never seen fescue before. I always say buy local. Buy for your environment. And so again, if you've got animals and you've got fescue and you know you got fescue, buy animals that are used to it. So again, and then again, pasture management. This was a large group. Lynette Edwards, Rebecca Payton, Louisa, Nancy, Jesse, Ricky, Mitch, Gustavo, Fernando, Heather, Gary Bates, who's our forage person, John Waller, Henry Freeberg, Mr. Fescue. He's got a book on it if you ever want to read it. Tulio Prado, Fred Hopkins, and then Scott Pratt at Clemson. And also, I sell hay. If you want to buy any, just give me a call. You told me I could put that on there, Kai. Yeah. So we also make and sell hay. So questions.
All right, let's thank Dr. Schrick. All right, we have time for some questions.
When you look at fescue, was the height of the fescue, the endophytes, is it worse at the bottom or I forget?
Seed and seed heads are the worst. That's why they're doing a lot of work on seed heads. You'll have people say get in there and bush hog the seed heads off. There's actually some treatments out there. I'm not a plant guy, so I can't tell you that will reduce seed heads and things of that sort. The highest level is going to be your seed heads. So that's why you're hitting May and June, especially May when those seed heads pop up, and water temperatures are doing in May. So that's why I think it's really a combo type effect. And one of the reasons that early on, a lot of the work we did was with ergotamine tartrate. Ergotamine tartrate is basically synthetic ergovaline. Same signs, reduced prolactin, increased rectal temperatures, increased respiration. It mimics it really, really well. And so we wanted to use the ergotamine tartrate, so we removed the nutrition question. Because you saw earlier there was a decrease in feed intake and all that. And we didn't want to have, is it nutrition or is it the actual product? And so we used a lot of ergotamine tartrate and everything until it got moved to Schedule 2 narcotic because it's used to make LSD. So I kind of lost that capability of using ergotamine tartrate, and ergovaline I couldn't afford. So that's why we went back to grazing the pastures. The problem with pasture work and seed, so fescue seed is a good alternative as well to get your ergovaline to cause the effect. But you have batch-to-batch variation, and you've got to really get it analyzed for ergovaline content to feel comfortable and have enough of that feed to feed over an entire 6 months or 9 months or whatever. So that's the problem with seed. And then the problem with the fescue is if you got dry years, different types of years, you may have a different density stocking in there of that, fescue, and you may say it's fescue, but when you actually start taking a plant scientist through there, he's going, well, that's foxtail, that's orchard grass, that's crabgrass, and it's not 100% fescue, it's a mixture. So again, is it the seed heads? Yeah, I think that's a big problem. And so that's why we get in there and tell them the bush hog and knock those seed heads off and everything. That's another management technique. But again, I think we've done a really good job selecting cattle that can handle it. And so I think that's the key, number one. We've selected cattle that can handle it.
One more question here in the back.
Will fescue hay do the same thing, or has it got to be the green grass?
Now, actually, with the fescue hay, as it dries down and everything, you'll lose the ergovaline content. It won't go to zero. It wouldn't be something that I'd sell to someone who's got pregnant mares. and everything like that. But in terms of beef cattle and everything, your fescue will drop down and things of that sort over time. So it's not going to be like the green grass. It's still going to be there, but not nearly at the toxic levels you're going to see. Now, I will not sell it to someone who's got horses and they've got pregnant mares, because then you're going to be in all sorts of trouble. So I try to avoid that. I want to keep selling hay.
All right, let's give another hand to Dr. Schrick. Thank you very much.